So all of us have the containers up and running. Like if you don't, then or whether you're experiencing some issues, related to this Docker Compose, kindly let me know. Like it's a matter of we can review that. But maybe just to refine this again, it's Docker Compose app and then -d. So that's how you start the Docker Compose, or rather the containers. So basically that's what I did. So if I run this, it will just show me that my containers are already running because they already are. So basically that's what we have. So are we together up to that point? If not, kindly let me know. Good. Then how now we want to see if the containers are actually running, because of course here we're seeing they are running, but are they really? So now you run the Docker PS. So Docker PS ideally is just a way of saying, okay, show me the running containers. So if you click enter, you see that we have different containers. So there is always a container ID, an image. Remember the image in Docker Compose. Then we have the command that is kind of initiating this. Then created, time it was created, and the status. So basically that's what we have. And the name. Maybe I have to zoom out a little bit so that you see everything. I hope you still can. So you see here we have the names. So these are the names of the containers as we gave it in the Docker Compose file. Okay, and then we're able to see clearly now the image that we defined and if it's healthy or not, because we remember we have this health check that is doing this, and then the ports. So Locust is running on port 8089, GeoServer normally port 8080, and then this is now the local ports, rather they are the ones which are here. So then the local PostgreSQL will be running on 5433, but the actual ports is 8089, 8080, and 5432. So basically that's how we do it. So now we want to access the user interfaces of GeoServer and Locust to see exactly now that we can access the containers. So I'll just clear this. So to clear everything that is in your PowerShell, you type CLS, or rather you can, CLS, and then it will clear everything. So I've just cleared everything. So I'll open my browser. So we are together up to that point. And then I'll type normally localhost, then port. So localhost, then the full colon, and then port number. So we'll start with 8080. Then / GeoServer, just up to them. So that will open our GeoServer, which is running as a container. So if I enter that, I should see the index.html, or rather I should see a page like this, which means GeoServer is running. Are we together? I hope so. If you have any question, please let me know so that we move together. Good. Okay. So we have now GeoServer, which we can access it on our browser. Perfect, Simon. So I'll just log in. Remember our credentials. You can also access them from our Docker Compose. So admin, then the password is GeoServer. So you should see something like this. So just one thing that maybe just something in production. You usually don't write passwords or rather the username and passwords inside of the Docker Compose file. Usually this is saved as environment variables. That is the production state. For us, we have it hard coded inside the Docker Compose file because of it's a demo, it's just internal and nobody will really access this because it's localhost. But when you are kind of publishing your server to a host name or somewhere else where someone will access it, please save these passwords as environment variables. So they should be just environment variables. So this is the interface that we have. Okay, now to access Locust, remember we saw that the port that Locust was running on was 8089. So maybe I will do again Docker PS here. So it was 8089, which is now our local port, and also now in the container also is 8089. So that's why I've written localhost, then full colon 8089. That's it. Then you should see something like this. So you see, it's a very easy interface to work on once you have everything set up. But this is just to show you exactly that. And you can see because we have it programmed inside the code, then you can see that now we have the name. So you can see that here it's not localhost 8080. Why? Because when containers are in the same network, they refer to each other the name of the service. For example, maybe I can just show you. You see here we have runs the service here is GeoServer. So that's what happens. So when containers are kind of in the same network, because all of these are running in the same network, they refer to each other with the name. So that is the name and the port. So that's why here you can see it's GeoServer and not localhost 8080. Okay, but that's the first part. So now we are sure now our UIs are running, and maybe it's high time maybe we check a little bit on if our PostGIS is also actually running. Now to do that, I'll use the command prompt, the command line. Why? Because using the UI might have its own complications with the localhost and everything. I tried and it did not work. So maybe you can try to open pgadmin, try to provide the details 5433 as the port and see if it will open. But I'll advise us maybe we use the command line. So now let's check if our PostGIS is running. So how do we do that? So ideally, it's also very easy. So Docker Compose has commands. So we can write together. So it's Docker Compose. So that's the first part. Then so this one is usually saying execute, or it's giving in the function rather. You see, so it's kind of saying run this as like a command rather. And then here you see we have written PostGIS, because that is the command, or rather that is the name of the service as it's known by Docker Compose. So that is the name. So the first part is Docker Compose exec is a constant. Then PostGIS is the name of the service that we want. And then now we run PSQL normally. So we say we want to run PSQL. So which is now for those who are familiar with Postgres. So we have PSQL, and then PSQL needs some variables. So we use our user, or rather our database, and then our user, which is GIS. So what are these? U and D are just arguments. And if we go to here to our Postgres, we see here we have DB is GIS, then user is workshop. So basically that's what we are doing. User is workshop slash hyphen U is workshop, then hyphen D is GIS. That is the name of the database. So basically that's all it has. So it's Docker Compose exec, and then I'll just copy this and put it in our chat as well, maybe for someone to copy paste if it's needed. So basically that's the command. And then once you have that, you enter. So if everything ran correctly, you should see now this PSQL command line, which now says you can say, for example, you can check the tables. So I'll just run something here, like backslash, or this backslash, I think, yeah, backslash DT, and then I put the semicolon. So if I run that, I'll see a lot of tables. Usually these are tables from the GeoServer, because we have it connected. But ideally now, that's just to show you that our Postgres is running. That is the main thing of this. So don't maybe have so much issue. So run this Docker exec as I've copied in the command in the chat. And then if it opens GIS, then you are fine. This next step is just, extra. So if you want to see if there are really tables inside there, then once you click enter, you can scroll down with the enter, and then you can see we have 38 relationships, or relations rather, which is exactly what should be expected. Okay, so our PostGIS or Postgres is also up and running. So to quit this, I do again \q and enter. And then I'm now from the container, I'm outside the container, now I'm back locally. And then I'll just CLS again to clear everything. Okay, up to that point. So maybe I'll give you like a minute, maybe to have everything set, or like 30 seconds or something. But before we do that, or rather as we do that, then we will navigate to GeoServer for the people who have just to see a little bit on the GeoServer. So go to the GeoServer, and then here I need to explain a few concepts. All these are part of load testing because they are very important on how GeoServer really works. So before we actually, then you see that in GeoServer we'll be using the GeoWeb cache. So GeoWeb cache is an extension, or rather is a feature in GeoServer which allows you to create tiles for your layer, so that people, when they kind of access it, they'll access it from these kind of already existing tiles. So basically it makes the entire, access faster and better and more, and your application, which is kind of using these layers, whichever, no, these are the default layers which are there. But whichever your application is using any of this, if you have this GeoWeb cache enabled and so on, then it will access it like fast, yeah, and not it won't take too much time. But now, before we do that, we need to kind of now publish our data. Remember, when we look at our Postgres, again, we are going back to Postgres. Please, let's go back to the command line. I'll run the command that we ran previously, which was docker compose exec PostGIS PSQL, then -u workshop -bgis. So basically, this is just to get into the PostGIS or Postgres container. So inside the container, I'll check the tables. So this is a very important table because it's part of everything that we are doing. So all these are default ones that have been published because of this GeoServer integration. But when I go down up to the end, I will see there is a table which is called places. So this is default, or rather this is what we have published during this initialization. So all these have it configured because I did not want us to do a lot of time there, but just so that I show you. Remember, when you run, just I'll zoom this a little bit so that you understand the ideally concept. So this ideally is not so much the focus of our workshop. The focus is load testing and so on, but it's good to understand how the things are kind of connected. So even if you don't really understand this fully, I'll say maybe you can refer to it later to see exactly how it's configured. But I need to maybe to explain it a little bit. So here we have this file, which is the init file, which we are kind of running. So if I go to the init file here, I am able to see that the init file, which is being run when the Postgres container starts, it's creating a table. Then it's adding some data. So this data is ideally just random data that I've created. So it's creating 10,000 points, which are kind of distributed everywhere in a specific zone. So basically, this is the data I would say we are using. But in a production setup, of course, you have your actual data. So this is just some seed data that I've created for the sake of this workshop, or rather, so it's being created also during PostGIS being started. So it's doing a lot of things, doing a lot of if else, case and so on. So case else, this is an if else in SQL. So case, if this is this is this, then this is this, and then later on you have this else statement when everything else here fails. So basically this is creating some if else statements, and then we are kind of inserting that data into the table rather. So basically that's what this Docker compose when we run it, and this file is kind of initialized, then everything is being run at that point. So don't worry too much about why this has appeared here, but it's because of that. So if I'm here, then I'll just type Q so that I quit that section of it, and then I'm back here. Okay. Are we together up to that point? So I'll just now move maybe to the next part. I hope now maybe Lawrence, you have the data and everyone else also has the data. So I'll just move straight to the point, to the next part of this. Then I'll just quit here. So now I'm back to the local directory. Okay. So what is the next step? So our next step would be, we need to start inspecting. Remember, we already have the containers up and running. So we need now to start inspecting our Postgres. So usually, maybe just this a little tip for everyone. So when a user kind of complains that your application is down, or rather your application is not working, when you are doing troubleshooting or RCA, root cause analysis, you start from the component that is facing the user. So you start with the portal or whatever the system the user is interacting with, seeing if it's on the user's side. As you go deeper, so the user is okay, so it means the issue is maybe the request, or the request is okay, then the issue is maybe the API, or the API is good, then maybe the issue is the database. All of those are okay. Maybe the issue is the network and so on. So that's how you do RCA. And when you kind of get a hang of these things, it kind of becomes, a rhythm, But now in our case, because we are doing optimization, we cannot start on the top, which is the GeoServer. We want to start from actually the database, because that is now the optimization starts from the database to the GeoServer. So basically, we'll be starting with to see how the database is structured. Okay. So how do we do this? So maybe for the sake of or to make it a little bit easy, I'll also maybe move again to the database, again running the Docker Compose exec, so that we run the SQL statement directly from the database. Ideally, I could run it outside, but it will be a lot of commands. So let me just run it inside so that they are just simple SQL statements. Okay. So now we want to, Postgres actually offers a lot of features that we are not aware of. So let's start with one of the things that we need to do. So if you are now in the GIS and you are sure that we have the tables, if you run DT, you are seeing a lot of things there, then we are together up to that point. Okay, so if you don't, then maybe it's you let me know so that we see how we could handle that. All right, so we are on the database level. We are inside our Postgres database. So we'll run the first command, which is \timing on. So \timing on will give us as duration. Every time we execute something, it will give us the time it took to execute that. So this is a very crucial, aspect of this, because now it enables you to kind of see how long your queries are taking. So we have now the timing on. So basically that's it, \timing on. And then we'll run the first command. So I'll just paste these commands to the chart again, because now we need that. We'll just paste the commands that I'm executing, but we'll be executing them one by one. So don't worry. So don't execute all of them at once. We'll just be executing them one by one. Okay. So I'll start with the first one, which is just a normal point count. We want to see how many points do we have in our table, which is the workshop dot. Workshop is the schema. So, and then the table name is the places. So I'll just write, I won't type it in caps, but it's advisable you write it in caps, but I'll just write it in small count. Then inside there, I'll put the all. So I want to count everything. Then I want to give it a name. You can type it or you can paste the commands that I send. So, but I just want to type it so that I can explain. Then select count as point count, and then I'll type from workshop dot places, and then I put the semicolon. So if I do that, I'll see my point count is 10,000. So I hope everyone has 10,000 points. So those are the points that are in our database. And you can see how long it took. It took 18 milliseconds to execute count function. So usually, maybe it looks small because it's 18 milliseconds. So there is 0.018 seconds. So usually it's not too much. But assuming you have a million points or rather a million rows that you have, then you assume that probably this time is not so good. But anyway, so 18 milliseconds to kind of execute that. Then we want to just execute a little bit of a complex one. So this is a bit long, so I'll also copy paste it and paste it here. So select, so usually it's select category. So I'm selecting two things. So category, then count. So I want to get a count of each category. So this is basically just simple, again, SQL statement. I won't go into details on that. Then I'll be grouping by the category and then order. So if I enter that, I'm seeing that every category, hospital, office, park, school, they have 2,000 points. So basically you can see how long it took again to execute this. 9 milliseconds to get the category. Good. Now let's go to the interesting part. I hope I can clear his scan. No? How do I clear this? Anyway, so I'll just now select the extend because now we want to do some spatial indexing later. So for now, I want to select st extend. And then the field that I'll be using for our geometry field is geom. And then from workshop dot places. So I want to see do wrong. Select stgeom from workshop. Okay. I'll just run this. Okay. Because I ran this initially. Okay, I don't understand what's wrong. No, this clear did not go. Sorry. So select extend from workshop places. So I just run that. And then you can see now getting just the geometry, querying the geometry of this layer. It has taken 59 or rather 60 milliseconds. So you can see the time is quite substantial. Yeah. But now lastly, I want to see if we have any indices. Yeah. So by default, we should see only one. So again, I'm not doing anything different. So just select the index name from a table in Postgres, which is called PG indexes, then schema, and then the table. Then I order by. So you can see by running that, I'm seeing that I only have one places primary key. So this is just a unique index for the primary key of the layer. So usually just this is the only thing that we have. And it took 38 milliseconds. Good. So basically that is just a simple interaction with our database to see how it's responding and so on. It's not so good, but you'll see it just in quite some time. Because I want us now to load test this and see how long it will take to do some different stuff. Okay. I hope we are together up to that point. And yeah, so I'll just quit this. So this was just a simple interaction. Is there any question on the Postgres part, the commands or something else there? Because now we'll be load testing the Postgres and to see how much load it can handle. And we'll be using now the PG bench. Okay, so is there any question from the participants? Kindly let me know if you have any question. Okay, good. So I'll just move straight to now the part where I want to show you a little bit on the code on what exactly is happening. So for the load testing, we'll be using an SQL statement. So as I mentioned, we'll be sending a bunch of SQL statements to the Postgres database, or rather to the PostgreSQL server, to see how long it takes to, or rather how much statements it can process. That's number one. And then what is the latency, and so on and so forth. We'll see a little bit of match metrics. So because our data is dummy, in a normal situation, again, you'll use, and this is just an extra part for you guys. There is an extension of Postgres, which is called PG statements. Yeah. So just I can maybe simply Google it here so that I need to be sure. It's called PG statements, PG start statements. So PG start statements, usually it allows you to track your SQL planning and execution. So which means is that you are able to see how long a specific SQL statement took. And it kind of keeps a record. You can also keep a record for that in the database as well. So that once you query, you can see, okay, this was the slowest statement or this was the fastest and so on. So there are a lot of things that you can do with these PG start statements. More so if your workflow is database heavy. If you are relying too much on Postgres queries, you don't have these, server in between like an API or GeoServer or any other thing, then this will be very crucial for you. So just FYI, kindly have a look at this because it can now guide you in terms of getting exactly what you will put here. Because what you want to load test is what users actually ask for rather. So you don't need just random stuff like I have here. But what I just did, or rather my simple aspect, what I have here is just showing exactly, or rather doing those simple queries that are here. So I'm kind of creating randomness, yeah? So I have the west and south extents, and then I kind of create this envelope as random. So every time I get a random XY, like X marks as X mean, Y, X mean, X marks, and then Y mean, Y marks. It kind of gets every different kind of extents every time. So this is basically what this PG bench spatial SQL does. And I've already copied it to you, so you have it. And yeah, so basically that's it for the what we'll be doing. So just creating some bunch of statements and then sending that to the database. Okay, so let's do that now. How do we do that? So remember Docker compose exec. Remember always that one should stick. So Docker compose exec. So this one I'll copy it because it has a lot of variables which someone might get wrong, but I'll explain this right now. So again, this is the command that I'm writing right now. Okay, so Docker compose exec. So that is the first part. And then remember, I'm doing PostGIS. So that is the name of the service. And then, or rather the container. And then I use PG bench. That is exactly what I'm using. And then now this is the initial part. And then I need to write the user. So the user is workshop. And then the database is GIS because that is where I'm sending my statements. In our case now, you might have maybe in production a different database. So this is the initial part. So you see, we have added a part there, which is exec PostGIS, then we have added PG bench. So not PSQL anymore, it's PG bench because that is what we are using. So once you have that, we need the first argument, which is -c. So -c ideally means the number of clients. So how many simultaneous clients are we sending in our case? Remember, we are doing now load testing already. So we need to send, let's say 10. So let's put 10 as it's in the script. So we are sending 10 concurrent requests, which is kind of simulating the number of users who are kind of now asking the requests on your Postgres database. So that is the first part. Then the second part is J. So J is the number of PG bench worker threads. So usually now PG bench is working it works with threads, the way it's kind of structured. So maybe in this case now, if you want to create more traffic, maybe you can increase the threads. But in our case, please, let's have it as 2. So we have 2 PG bench threads. Then the other thing is the time. How long do we want to load test this? How long should it take? So we want it to take 60 seconds. So the time here is in seconds. Then the other part that we need is the P. You can get, you can add it, but P usually means P, and then we say 10. So P is progress. So we want to say every 10 seconds, give us the statistics. So you'll see it in a bit. So again, so we have that client, number of concurrents, 10, number of PG bench instances or threads, 2, number of how long it will take, or rather how long we are load testing this, 60 seconds. Then the progress every time will give us feedback after 10 seconds. Then finally, we add the -f, which means now the file. So the file which it will be using to do this. So it's /workshop. Then remember pgbench -spatial.sql. So where is this workshop coming from? Because you remember now, if I go here to my compose, remember all these are in the compose file. So that's why the compose file is very important. You see here, pgbench spatial SQL, this is the local directory. Then I've mapped it to the container directory, which is workbench, workshop, pgbench, blah, blah, blah. So basically that's what we are doing. So here you don't use the PostGIS, the local directory. We are using the directory which is inside the container because we are running this inside the container. Okay, so if we are together up to that point, is there any question up to that point before I hit enter? Or maybe I'm sure maybe some of you have already done it. But yeah, I'll enter this. So it will give you a bunch of stuff. So that's not so much important. We want to see it up to the end. So it will run for a little bit of 60 seconds. So before it finishes, I had created a table here. So I've created a different measurements metrics that we have. And then before, this is before the, I do the, sorry, before I do the indices, the spatial index rather. So this is how long it took. So this was a test that I was doing before we started the meeting. So now these are the things that we'll do. So we have not done any spatial index. So it's just a normal primary key index. So our thing is still running. So this is the table that we'll be using to compare if there is any improvements based on any other thing that we'll be doing. But remember, the spatial index is just one of them. So you can create an index for a specific field. Maybe if a specific field is being queried most often, or you can create an index for other fields as well. You can also, there is also additional components or other additional aspects on the Postgres that you can do. You can increase the number of instances of your Postgres server. You can increase the RAM even for where the server is being hosted and so on. So all these are part of the things you can do to optimize the performance and load testing as part of after the results of your load testing. Yes, Wendy.
Yes, Ken. I'm a bit confused about the spatial indices. Which spatial indices are these?
Spatial indices. Oh, okay, is a spatial index rather, not so much of a plural, but spatial index is we like just creating a spatial index for the geometry field. Yeah, because as you remember here when we did, okay, it's already done. But I'll just rerun this because we have a geometry field because our data is spatial. It has location, right? But when we did some query, I have to maybe go inside the container again. If when we did this, search select st extend, you remember that command. Usually what it does is that it queries this data. It is doing a spatial query, So when we are doing a spatial query, the field that is being used is the geometric field. So if you have published data in Postgres, you remember that it has this geometry field that comes into play. So by default, maybe it's called geom or something, but you can also name it anything. So usually now this geom field is the one that is queried during spatial queries. So in our case, what we are doing is that this spatial index that we will create later on, we have not yet created it, will now kind of be based on this geometric field. And the expectation is the time that it takes to run our spatial queries should increase, or rather the response time should be better compared to before there is an index. So a spatial index ideally is kind of now creating that internal structure of Postgres, which I actually don't have so much details about, but yeah. So it creates this index that enables the querying of a specific field to be faster. So the spatial index will be on the geom field, so to allow us to achieve that. But we will see it just in a bit. So now our load testing is actually done. Interesting. For 60 seconds, we have run this. So what is important, leave alone. So if you go up, if you scroll up on your load test, you will find a lot of things. So basically, because these are, you see, this is a query that is running literally every time. So it's creating, you see here, it's running a different value, you see, every time. So these queries are usually, and you see now, like here, this is where I was talking about, maybe Wendy. You see this here, we are creating an envelope. So we are doing select by location, the one that we do in ArcGIS Pro. So we are selecting by location. So in this case, to select by location, it means that it's using a spatial component or the geometric field. So therefore, we are doing this location to create kind of a rectangle where we'll be now kind of fetching that data. So basically, that's it on that. And then we should see some posts progress somewhere. Maybe it's sending a lot of them. But if you scroll up, maybe you should see some progress in between. Like see here this PG bench, then you should see somewhere where it is saying there is some progress that is showing. Yeah. So usually it should show after every 10 seconds. But now my focus now, or rather our focus is this part. Okay, let's see. So number of clients, 10. Remember? So we are simulating 10 concurrent clients. This can be users, this can be applications, this can be, whatever. So number of threads we put 2. Now maximum number of retries, duration was 60 seconds. So here is where the numbers matter. Number of transactions actually processed. So you see, these are 32,724. So I'll just put that in our table. So this is that. Then failed transactions is 0. So we put here 0. Then average latency. Now this is also important because it shows how long the query had to wait. Average latency, very important. So we see latency here was 18 milliseconds. So with this quite some time, maybe if you have worked with production databases, you will see that 18 milliseconds for a query to kind of be run, it's not that fun. Then standard deviation for the latency, you see the difference was, again, very, very big, from the fastest to the slowest. You have 10 milliseconds in between. So I'll just type this as 10. It's 10.5. So I can type it 10.5 maybe. But you will see then total transactions per second. Now this is what we call throughput. So throughput is how long, or rather, how much request can this database server handle. So in our case, for 60 seconds, the throughput here, which is TPS, TPS was 545.4. So 545.4. And then we have a query plan. So usually query plan is what exactly is Postgres using to query this data. Okay. So to see what exactly Postgres is using to query this data, I'll just need to copy one command here. So I'll just again paste it in the chart. This is the command that maybe we want to run so that we see the details. So this is just a single command, it's not load testing. So that is a command I posted in the chart. So I'll just clear this for now because we have gotten all the details that we need as of now. So I'll just clear that and then I'll run this command. I have pasted it in the chart. So ideally I'm doing some PSQL again, and now I'm doing some explanation. Then I'm selecting based on area. Now you see here, I'm again doing select by location, logically what is there in GIS software and so on. So I want to select by location and see what exactly I'm getting. So if I enter, then I see this query plan. So that is the essence of this analyze or rather explain. So here, I want you to take note of this part. Sequential scan on places. Then we have here some costs. So this cost is not in milliseconds or anything. This is an internal calculation. Then you see, so this was the approximation. When I ran that command, the planner, or rather the SQL Postgres estimated that 604 rows meet my query. But actually, it returned how many rows here? 603. So you see, this was the initial estimate, 604, but it returned 603. So usually that's how it works. But I want to kind of now mention this part of, sorry. Okay. So I want to mention this part of sequential scan. So from the name, as the name suggests, it means that Postgres, or rather the Postgres in this instance, queried, or rather went row by row, checking, okay, does this row meet the query? No. Goes to the next, like that, for 10,000 rows. How do we know that? If you come here, you see rows removed. You see how many? So if you add this with what was got, it will give you 10,000. So which means that PostGIS, or rather Postgres, went row by row, checking each row a condition. So assume you have 10 million rows, for example. You see, it will take you some substantial amount of time to go through everyone, each and every one of it. Then you can see the execution time. It took 2.5 milliseconds. Please, let's take note of that, because maybe it will also be crucial. So, but of course it will vary. If you execute that command again, it will give you maybe a different value. But let me just put that as here, so that we just track it as well. So this one took 2.4, 2.5. Okay, 5 is okay. Then this is the query plan. So for every stuff that we did in the load testing, it was doing this. Why? Because we don't have a spatial index. So I'll just write here sequential scan, which means that it is doing row by row. It is going row by row. Okay, that's it. So that's the first part of our load testing for the Postgres. So we're moving. Any question up to that point? Before now we implement a spatial index, which is again a very simple query, which is very easy to kind of execute. Okay. So if no question, are we together then? Are we at par?
Now I've been able to get the tables, and but I'm trying to run the query on the PG bench. It's saying the workshop that file or direct does not exist. That's what it's saying. I know it's there. I don't know why. It says workshop slash forward slash PG bench special.sql does not exist. Yeah, I know that.
Did you run Docker Compose down before?
Do I need to run it down before?
Yeah, exactly. You have to, yeah, because if you don't run it, then it means that the file is not in the container, and that's why it doesn't exist. So for your case, just run Docker first before you do anything. Just run Docker Compose down -v. So -v means volume. So we want also to remove the volume. You can say the volumes that were created, which kind of store the data. So we want kind of to delete everything. So I won't run it myself, but run it on your end. And once it has completed successfully, then because already I believe your structure is like mine. So maybe let me minimize this like this. So I hope you have this the root folder. So I hope you have now the Docker Compose, and then you have created a folder inside, like a folder which has now the 3 files that I've sent. So basically that's what's needed of you. Yeah. Okay. So yeah, so you just need that, and then run Docker Compose down, and then after it has finished, then run Docker Compose up. Remember to run down, then -v, so that you remove the volumes as well. And then after up, then -d, you create it as in detached mode so that now you can run additional commands on this window. Okay, so basically that's what you need. And then now from there, now you just need to execute this PG bench, and you should see something. Yeah, it should not give you that part. I feel like it's because this data was not there in the first place. Anyone else experiencing challenges on doing this first part of the load testing? Okay, silence means we are good, or we are confused, or what? So, talk to me, guys. Are we good? Yes. All right, man. Means that we are fine. Maybe some are scared to talk. So I'll assume we are good. Please let me know if maybe you are yeah, Lawrence, is good that you are kind of now asking the questions if you're stuck. So that's pretty good. Yeah. I don't know, maybe if the rest we are together. If not, please let me know. It will be very helpful. Yeah. Just to get a note that you are good or not. Yeah. An emoji will also work. Yeah. Okay. Great. So I have that, and then now the next part was, now we want to create a spatial index so that we see what is the difference between these two. Yeah, what is the difference between when you have this spatial index and when you don't? Is there any difference? There should be, but this only affects because we are doing spatial queries. We are spatial engineers, we are geospatial engineers, we are, GIS analysts and so on. So most of our data, 99% or even more, I don't know, has a location component. And therefore, spatial queries is kind of part of our daily life. So basically, that's why here we are focusing on the spatial index. All right. So to create an index together, maybe we could, if we remember the Postgres that we were using is create, okay, sorry. So I'll run this inside the container, okay, so that we see what's going on. So remember that exec command that we were doing. So please let's use it again so that we go inside the container. So compose exec. You can also, if you have it already, you can use the up arrow to navigate to where it was, which is quite easier than typing everything again. So for me, I have it already. So maybe you can click the up arrow to go through the commands. So once you have it, then we need now to create the index. So we'll write a command here. So I'll just write in capital letters so that we as needed. So if not, then create index if not exists. So this is quite straightforward. Create index if it doesn't exist. Then the name of the index. So we'll call it places underscore geo underscore index. So that's the name of our index. That's how we will call it. Then, so that's the first part. So again, is on which table are we creating this index? So we write on, again, workshop dot places. So that's again the second part. Then the last part is which field are we creating this index and what technology rather are we using? So you say using GIS, then the name of the field. So basically that's it. So we have defined create an index if it doesn't exist, or if not exists, then the name of the index, and then which table are we targeting and which type of index. So we are creating a geospatial index, and which field has the geospatial component or component, it's the geo. So basically that's what we have, and then we put the semicolon and we enter. So ideally that's just it, and we already have our spatial index, just like that. Okay, so basically this GST is specifying it's a geospatial, or rather it's a spatial index. Okay, great. Since we have the index, we can see if really the index was created. If you remember, we had a command. So again, that's the beauty of the up arrow. Again, I can just navigate up until the first part where I was doing DT, but my focus is this part of selecting the indexes. So you see, remember this command. So select index name, then index definition, then from the table and so on. So in this case, we expect we should have two indices, the primary key index and the spatial index. So if you enter that statement, then you will see exactly that we have two indices, which is now the spatial and the primary key one, the unique index. So we have a spatial index and we now need to use it. So up to that point, do we have an issue? So we want to kind of just, now this is the final part of Postgres, and then now we'll just move to the GeoServer for a couple of minutes there. There isn't much there, but yeah, here it's good to understand also how Postgres works. All right. Do you have a question? Do you have a question on this? Okay. Brian, are we together?
Yes.
Okay, good. Ayete? Perfect. Miss Bao? Abdul? Perfect. Lawrence? Did you catch up? Good. Wendy, are you able now to follow through or? Okay.
Yes, Ken. I am following through, Sasa.
Okay, perfect. All right. Yeah, so we have our two indices already set up, and now we need to remember that command that we ran, that we got these parts. Remember, we ran so that we could see the execution time and the query plan. So we need to rerun it. The same query, actually, nothing, we don't need to change anything, so that we see if there is any difference after applying the spatial index. This is very important as a comparison. So we don't need to change anything. So I'll just navigate. Actually, it was it? Yeah, it was. I'll just navigate. Just pick it again in the chat. I had it. So it was in using Docker Compose. So because I'm already inside the container, I'll remove the Docker Compose part and just pick the explain. Sorry about that. So I'll just pick. So remember the last command that I sent to you. So these are, it has the Docker Compose, explain, blah, blah, blah. So I've removed that because I'm already inside the container, so I don't need the Docker compose thing. So I've just picked the command. So I'll just run this. Basically, that's what I did. I haven't changed anything, so it is the same logic, but I want us now to focus a little bit on some components. So you see, this one is very different from what we had. So one is that we are using now bitmap heap scan. So we are not using sequential scan anymore. So I'll just explain that in a bit. So I'll just write here bitmap heap scan. Again, the last thing maybe to check is how long did it take? Look, execution time, 1 millisecond. So that is 0.8. So it was 2.5. So it has improved to 0.8 just by adding a spatial index. So you can see the power of spatial index. So again, it's 0.8. But now I want us to see a little bit. So here, you see, what I want to show you actually is this part. There is what we call the shared heat. So which means that 35 of the results that we got were already inside Postgres. You can say cache. Yeah, you see in Postgres we have what we call the write ahead log or something of the sort. Yeah. So what this does is that it means that Postgres already kind of had this data stored locally, or rather inside its configuration, which means that it did not query the table directly from this number of data sets. So it took this data from its own cache, and then now for the rest, which here you can see that it's the same thing. So the rows returned were the same, 603. So it's nothing different. But also we have this index condition. So you see, this was not there initially. So you see now it's kind of now doing some geometric condition querying. So first it did a recheck, and then later on it did another check just to confirm. So basically this is how it works. So first it does the checking, and then it does the final check to see if the data that has been returned is really, or rather fits that criteria. And one thing that I want us also to see is that here you don't see the data that has been missed or rather has been removed. Why? Because now it doesn't really go row by row, but rather does kind of a scanning. Yeah. But I want us to focus on this part whereby we are seeing that the time has improved, or rather the execution times is quite low than, rather it is better than it was initially. As you can see here, it was 2.5 milliseconds. So this is time is in milliseconds, and it has gone to 0.8. Good. So that's the first improvement. Lastly, or rather the last part of this, I hope we are together. So I'll just type Q here to quit. The last part that I'll do is that I'll run the PG bench again with the same commands, everything, and see how many transactions, all the other components in this, how many transactions, average latency, throughput, and so on. So we want to see that. So we won't change anything on the PG bench. So I'll just quit here. So just /Q so that I get now the Docker compose thing that we had previously. So just clear this. So I'll just navigate to where it was. So this was it. So I hope we are together up to that point. Sorry. So are we together up to this point, guys, in terms of, every process? Are we understanding the concepts and so on? Of course, you can also post the question in the chat if you so wish as well. If it's something you can post. Okay, so we have Docker compose exec and every other thing that was initially. So I won't explain this again. So I just run this, and then we see in 60 seconds how long, or rather what metrics we'll get. So as it runs, because it will take some 60 seconds, I want us to go back to the code. So everyone maybe go back to the script. So I want us to move to maybe after we'll be doing this part for the Locust. So I'll copy this file. So I'm just trying to copy this file that we will be using for this. But if you have got the repo, then it should be okay. You don't need this file, but I've just pasted it. This is the file. So create another folder, just the way you created for PostGIS. Create a folder and type it Locust. And if for some reason you don't have like this data was not there initially, then you might need to rerun something. So I'll just be showing you before, if you did not have the data, that's what I mean. But if you ran this initially and you had everything, then you are fine. You don't need to do anything. Okay, but before then, maybe that's just make sure you create the folder. I hope we are set. Maybe a few seconds to create that if you did not have it, as we come to maybe our final, almost like an half an hour. So because we started a little bit late, I hope that's okay. As we, yeah, I think that will be more than enough. Okay, good. Right. I'm seeing some. What? Oh, okay. It's kind of reading this wrong. So do you have everyone the folder and the Locust file? Because that's now for the next step. But just as you copy that, I'll just let's just turn our heads to this part to see what really we have. Now, after implementing our spatial index, we have something here to show. So the number of transactions, it's now 133,000. So I just copy this. Then the failed transaction, that is the good thing. We don't have failed transactions. So you see, it's 0% or 0. So I'll just type there 0. Then average latency, it's now 3.9 milliseconds. So 3.9 milliseconds. And the latency standard deviation, which is this one, is 3.7 milliseconds. So 3.7 milliseconds. And the last part, throughput per second, or rather the transactions per second, which is the throughput, it's 2217. 2217. So are you guys seeing any improvement from these statistics? Any comment? Any observation? It would be good to hear if maybe I'm the one saying this wrong, or anyone who has observed something, maybe you can unmute and say. Okay. All right. Okay then. Yeah. So what I've seen is that transactions, or rather, have improved from 32,000 to 133,000, which means that now Postgres is handling many transactions compared to what it was before. Then failed is there is no issue. It means our Postgres is still surviving. So now nothing has failed yet. Then for the average latency, it means that it has improved from 18 milliseconds to 3 or rather 4 milliseconds. That's pretty good. Yeah. And then the latency also, the standard deviation is quite good. It means that most of the queries have the same latency, which means that there is not so much of a faster, so much fast, or so much not like a slower request. So it means that it is pretty good. Then the other interesting feature is this one, throughput, which is the transactions per second. It has improved from 545 to almost 4 times, rather even, yeah, I think it's even more than 4 times what it was initially. So you see it's now 2000, which means now this has really enhanced how Postgres is responding to everything. And this just shows you the power of spatial indices. Yeah, so if you have and this is just one of the ways to improve your Postgres, So if you combine this, as I mentioned, with the vacuuming of your database, with your compression of your database, with your, usual maintenance task of your database, then this value can be even higher, like better rather to say, because now we haven't done any vacuuming, we did not do any, improvement in terms of system resources and so on. So we are using literally the same thing. So if these values are not better, then you go to those other steps. You try the different methods. You try to optimize the database further and further, and maybe after some time you'll achieve values that really matter. Because now most of us have SLAs, which is service level agreement, that you have established with the users that your database will respond at this particular period, or rather, this is the duration. So if that is not met, then you kind of pay, you are fine. So in this case, it might be very crucial to make sure that this value, and this is just one run, so notice we just did one run for this before, one run for after. So usually it's not like that. So you have to do that a couple of times, maybe 10 times, 100 times, create a script that runs 100 times and then gets you the average, and so on, so that you have a better view of exactly what is happening. But once is not really, so much telling, but at least you can see the indication. So, and so on. Good. Perfect. So that's it from our Postgres optimization. So we'll be moving to Locust, or rather to GeoServer. And I'll need to maybe ask again, everyone has the Locust file and everything is there. Like you have the Locust folder and the file that I've sent it to you. And are we set for Locust? The next question will be, is there any question on this Postgres part? Because now we won't touch Postgres again, because now we would have moved our data to GeoServer, so we'll be handling it from GeoServer in a minute. So is there any question on what we have done so far on the Locust stuff and everything? Be good. Maybe show me, maybe you're okay.
We're good. I mean, for me, it's good. We can move on. So.
How about the rest? Are you also of the same opinion? All right. Okay. So we are good now with Postgres, or rather we are done with Postgres. So I'll just so I also, sorry, but I also need you to copy. I need to copy this file as well. So the repo has everything, but just for those who might not have gotten the repo, but if you downloaded the repo, then everything is there. But I'll just again send this file here. So you can create a folder, or rather you can create a folder called scripts and then save this file there. So what this file does, as you create that, just to say, this file ideally automates the process. So what does it do? It publishes the layer, it creates a Postgres data store. Remember, I'll be showing you in a few. So in GeoServer, you have to create data store, or rather the stores. So it creates the PostGIS store, everything configured, and then publishes the data which is in our Postgres. Remember this workshop places layer, or rather table, it publishes it to the GeoServer in 2 instances. It publishes one as uncached, because we want to see what is the difference between caching and uncaching. How does it affect everything? So it publishes 2 instances, caching, like a cached layer and an uncached layer. So we'll be going that into detail, or we'll be going into detail in a few. But that is what it does. So this is something that also you can use. You don't need to do this manually. It takes a lot of clicking. But once you have this, you can run it literally in a millisecond. You don't need to always click, and to register the store and so on. But this is what this does. So it publishes two layers, so called workplace and cached, and workshop like places cached. And then we can see that. So just before we go there, then I'll move to GeoServer so that I can show you exactly what it does. So before you publish a layer to GeoServer, first you need to say where is the layer coming from, or where is the layer coming from. So if you go to here to stores, sorry, I have to log in. So I hope you go to localhost 8080/GeoServer, and then you log in admin GeoServer. So this should give you should have 24 layers by default before we do anything. So I'm just explaining a little bit on the GeoServer part as you prepare also the folders and everything. So if you go to stores, you'll see these are the default stores that come with GeoServer. But because we want to publish our data from PostGIS, you need to click here, add new store, then PostGIS database. So once you click PostGIS, then you need to define a workspace. So I always advise that you need to create a workspace before, so that everything is together. So I just so this is just, I'll just put it with a 2 because the script will create the workspace by default as well. Okay, the script also creates the workspace. So it creates a workspace, registers the PostGIS store, and then publishes the layers into the two, cached and uncached. So that's what this PS PowerShell script does. So I'll just make this the default workspace, then I'll run that. So you see now we have our workspace. So then I'll go to stores and then add a new store, PostGIS. So I'm now registering. You see now because it's the default is being chosen. Then I say this is a demo. And then here you see these are the connection parameters of your Postgres. So whether if it's in domain.com, maybe it's hosted online, then the port usually is the same. It's the default. This is the default, so maybe it might have been changed. So again, another good to check. Then the database that you want to get the data from, I'll say maybe, test DB. These are the schema. Also, if it's a different schema, workshop schema, the user and the password and everything. So all these details are provided during registration. Then the minimum connection, maximum connection, and so on. And the batch insert size. You see, this is very important. If you're inserting 100 million rows, if you write one, it will take forever. So maybe you might need to increase this number so that now it kind of creates this. Then you have the connection timeout. How long will the connection be validated such that if a response is not received, then GeoServer will term that connection as having failed. Okay, so this is where the connection timeout comes into play. So if you know that your network, maybe you have a lot of latency, again, the topic of latency and so on, then you might need to increase this to some good value, maybe 300 seconds and so on and so forth. So those are the key ones, and then you apply. So I haven't created here, so I can say here is user. So these are just, just to show you. So the script will create everything. Yeah. Good. It's taking forever. Unable to obtain connection. You see, so the connection has failed because now I've created something here that doesn't exist. Anyway, that was just to show you how the registration takes place. But yeah, this is basically what now our script will be doing. So do we all now set up the script? I hope we have the script already created. So we need now to run it. So here you just need to, in the PowerShell. So this one is just a normal PowerShell because you don't need to go into the container. I would assume. Just a moment, I just confirm on my notes, in my notes rather. Okay. Yeah. So we don't need to run it inside a container, but rather outside. So you just need to navigate to where it is. So again, because I already know, so I have the script folder, and then I have the bootstrap PSI or PS1. So this is the file that I'm running. So if I run this, it does literally everything. You see, it first checks if the GeoServer is reachable, then it creates the workspace, then it registers the PostGIS data store, then it publishes the layers, as I mentioned, the places uncached, and we have now the places cached. Then it is kind of sets some settings to on the data, which I'll be showing you in a few, and that's it. So it kind of just returns these different folders, these different URLs for reference. But that's basically what the script does. It does exactly what I've shown you here. So once you have the data store, of course, now you need to go to publish the layer. So you just need to go to the data store. So I'll just go to the data store. So you see it's already here, but I'll just click it and then you define. So this is the data store as it is. And then now you kind of now publish the layer from there. So you add a new layer. So you choose the data store, and then it kind of shows you exactly all the layers which are there. And then you can publish it again if you want. Okay, so but basically that's how you publish a layer. So you kind of now fetch that data, and then you can publish it from here. Okay, I hope we are together up to that point. So I'll just move to show you the data. So once that script has it run successfully for everyone? If not, let me know. So I'll just refresh this, but already it seems that it has already picked it. You can see now my layers are 26, not 24 anymore, because now I have these two extra layers, the places uncached and places cached. Okay, let me go to the layers. So these are the two layers that have been added. You can see all of them are from my PostGIS store. And if I go to the store, to see just exploring the data, if I go to PostGIS, you can see this is the hosts. You see the host here is what? Because I remember I told you that inside the container, rather when the containers are in the same network, they refer to each other with the name of the container. Okay, so that's why here we have PostGIS, because the name of the PostgreSQL container is PostGIS. So it's not localhost anymore. And then you have here everything, all the details, you can see them there. And then all these are left out. So it's something also you can play around with and see how it works, or rather if there is any difference. But that's how it works. So basically this is what the script has done for us. So we have the store, we have the workspace, and we have the layers. So do you have any question up to that point? Okay. So let's start with the uncached layer and we'll see how it looks. So I want to focus on exactly what we'll be touching when you're doing load testing. So for the uncached layer, if you go to the layer itself, there is always this tab called tile caching. So if you go to the tile caching, you'll see this is enabled by default in most instances. But you can see that tile caching for this layer is disabled. So this is where GeoWeb Cache comes into play. If I enable this, then it means that I've enabled this layer for GeoWeb caching. And that is exactly why I have it in the script and deactivated, so that you could see what's the difference in terms of the response and so on. Okay, so this basically it. So you have the tile caching, which is disabled by default on this layer and cached. That's number one. Then the next part, if you go to the cached one, of course you expect it to be enabled. So if you go to tile caching, you see now this is enabled by default. So this is the GeoWeb cache, basically. So by enabling this, we are kind of now enforcing the GeoWeb caching. And one thing you have to know is that this GeoWeb caching can only work if your layer does not change so much frequently. And that's why it's being used with map layers and so on, layers which are not constantly changing. But for your vector data, maybe you might need to create a script to be fetching that data, republishing that data every time it changes in the database. So again, that is something that you can, again, play with and implement a simple script. It's very easy to automate these things nowadays. To create a script that kind of checks the timestamp and publishes that layer so that you always have the current if your layer is changing. But it's advisable that you do this for layers which are not changing frequently, something that you change once per month or once per year, then it's good to cache it so that it doesn't waste system resources, or rather it doesn't consume a lot of system resources. Good. So now we have that, and then I'll just move to the URL. So if you go to the PowerShell, you see that there is two URLs. So there is the default. So let me just preview this. So if you go to layer preview in your GeoServer, and then you go to the uncached one, open layers. So I just open it in a new tab. So you see, I want us to see the data. So this is how the data looks like. So it's very weird data, don't worry. So it's just created with circles, some outliers and so on, so that it kind of shows that difference. But anyway, so this is how it looks. Yeah, so this is the data that we have. And if you go now to the other, this one, so if you open, so I'll just open these URLs. This is the cached one. So again, I'm just copying it. So I'm copying this one here. So I just enter. So I'll just explain that in a bit. But what I want to focus on here is when you go now to the cached one, if you open it, it will open normally. You won't know if it is cached or not. You see the URLs, WMS service, blah, blah, blah. Then this one, service, WMS, like that. So it's the same thing, but the one is cached, another one is cached. And this is now where the GeoWeb cache comes into play. So if you come now to this, you see when you see this URL here, it's now GWC service. So the old one was workshop, WMS, then like that. But now here is the GWC service, and the rest of the thing remain the same. So these are usually now these are the tiles. You see, these are tiles that we are kind of fetching from the GeoWeb cache. So basically, this is how the URLs are structured. So you can see these are simple tile. So it means that if user is kind of in this area, this data will be shown pretty fast because it's already cached as PNG in this case. Okay, now back to maybe a little bit more. So yeah, so basically that's how it looks, and this is the URL. Don't worry too much on that, but I'll just be moving to the GeoWeb cache to see how it actually looks like. So again, you can open it in a new tab. So it's just GeoServer, like your URL, GeoServer, then GWC. So I'll enter that. So this is now the URL for the GeoWeb cache. So GeoWeb cache looks like this. So it's a tile cache for WMS, and it supports different KML, for example, Google Maps, and so on. So you can see it is very, very good. And then there are some statistics here. Doesn't really matter right now for us. Let's see the configuration file, where the configuration file is in case you want to change something. And you see here, local storage. This is the storage inside the container. So you can see how it looks like. So these are not so much important as of now. What I want us to do is that we go at this part of automatically generated demos, a list of all layers. So you see here, we have layer name, enabled, grid set, and so on. So you can see all of these are true, except one, which is this one. So this is how it looks like. So if you go to this one, so here I want to explain two components just briefly. So we have the seed, to seeding, and we have the grid set. So what is it? Seeding ideally means is that you are pre-generating Okay, you are pre-generating the tiles before users request them. So by default, if I run this query for this cached layer, it now generates it on the fly. So if I request this area, I get my tile. If I request that area, I get another tile. If the next user requests the area that I requested, they get it from the cache. Why? Because I already requested it. It has been created. Now it's there. So that's how it works. So what does that mean? That it means that the first user usually experiences some latency. Yeah. So in a situation whereby you don't want that, or you want to pre-generate them beforehand, then this is where the seeding comes into play. Because now the first user usually will experience that slowness as the tiles are being created. Okay, and exactly that is how it works. But now seeding these layers, again, you need to know exactly how we want to seed them. I'll be showing you in a few. Then grid set, just as the name suggests, is actually the coordinate system that supports that grid, those tiles. So which means that if a user requests this data with 3857 EPSG code, then these tiles won't be used because they are not there. So it means that now that data will be queried directly from the database. But if they request exactly like this, then the already generated on the fly or pre-generated tiles will be served to the user. So that is the only, not the only, but that is the thing to do with this. So if I click to seed this layer and I come here, there are a lot of things that I have to choose. So the one thing that I want to show you is that you can, if you come to the type of operation, you can see reseed to regenerate all layers, or seed to generate only missing tiles. Then truncate to remove the tiles. These are very dangerous operation. So I'll just maybe click reseed. And then you see here, we have the grid set already. Then we have the format. Then another crucial part where I was saying that the seeding, the manual seeding, also you need to understand how your data is because you need to define the zoom levels. So maybe I want to start with zoom level 0 to, you see there is up to 21 zoom levels. This one will take pretty long time to seed if you have a lot of data. So usually now it's very important that you come here and you only seed the zoom levels that are relevant to your users. Because if in your map, you have done this filter by scale, or, you have kind of configured this part whereby this layer only appears at specific zoom level. And I'm sure you understand what I mean. It means that you don't need all those other levels, So if this one is only appearing at higher levels, then use higher levels. If this is appearing at lower scales, lower zoom level, then use that. So that now you only provide the data that is needed by you kind of prepare the data that most of your users will be using. So that's actually the importance of this. So you have that control to pre-generate exactly what you want. So I'll just create a random one here. So you see, you can provide your bounding box if you want, based on where actually you want to generate your tiles, and then you submit. So it shows you something like this. It's running a reseed. So it is estimated 244 tiles, then 80 tiles complete, and some details here. So if I refresh this, then it seems it's already done. So currently there are no tasks. So that is done already. But anyway, so that was just an example. So that's how it works. There is the seeding. And then if the grid sets, you can define your own grid sets as well. If you scroll here, you'll see a lot of grid sets, which are most of them will serve your purpose. So in case you want to change, for example, you want to change the zoom levels on your default, you just create a copy and then you can remove. Maybe you say I don't want these zoom levels and so on. You just remain with the zoom levels that you want. And then once you are kind of using this to publish your layer, it kind of is already on your zoom level. So you don't need to define it later on. So that's just a tip. So basically where the grid sets kind of comes into play. And when you have to define it with scales, yeah, as we understand. So you can say I want to use this is 279 million. So I will say I want to use 270. Okay, which one is this? This is mine. Okay. So this is the pixel size. So I'll just use this instead. So because the zoom level using the scale is easier than for me, that is, you can use 270 mil and something like that. And you see now by that, the pixel size adjusts and so on. So I can say that is my highest level and so on. So you can customize these the way you want, so that if someone scrolls, they go exactly to the zoom level that you have defined. So that is the advantage of this thing. Okay, so a lot of talk. So basically that's the things that I wanted to mention on the GeoServer. And we need now to run the Locust aspect so that we finish on this, because that is the final part of this, because this is ideally what we will be looking at to finish this workshop. Okay. All right. So if you have the file, or you created the file right now, so maybe let me just show you exactly. So you need to run, I just need to check, run the final command for this. If you don't have the data, or rather if you just copied the layer that I've created right now, you have to run docker compose, then locust. So we want to kind of recreate the locust container, because that is what, then I think, okay, docker compose app. Hope this is the, okay, post recreate. Is it? Yeah, okay, I got it. Sometimes it takes, okay. So I'll just refer to it. So you run this command, docker compose app, then I'll put this -d so that I can input. Then you type the name of the container, which is locust, and then you use this force recreate. What does force recreate does? Force recreate kind of recreate, or rather regenerates that container, only that container, not everything. So that's what I've done. So I've just rerun that, and then now, so that now my file, the locust file that I've sent to you, is part of your containers. Okay, good. So now, since we have that, that basically means that we are ready to go. So is there any question before we do our final part of our workshop? Because this is the, cream de la cream of the thing. Okay, so now load testing in Locust, usually you create the number of users at peak concurrency. So remember, with the PG bench, we are defining, okay, we want 10 users. So basically this is the same concept. So in this case, you can say we want GeoServer to have 500 users. That is the maximum value of our users. So we're estimating that on peak times, we'll have 500 users. And then ramp up. So users started per second. So we want to say, okay, how many users do we start with? And how many will be added per second? So we can say we want 10, or rather, we want 10. So we will be adding 10 users every second. And then this is the URL of the host that we are doing. And then you kind of run that. So if you go to the charts, you can see something happening. So you're able to see total requests per second. You're able to see response time. You're able to see number of users. So if you look here, you can see how the users are increasing. And then up here, you're able to see the users which are already running. Okay, so here you can see that we have 350 users which are running and everything. Okay, so basically now this gives you a very good visual on everything. So you can see how it works. But now my focus, I want us to go to this part of statistics. Again, this is not giving me the response that it should. But anyway, the difference is very minimal, maybe because of the number of data sets that we are querying. But I want us to see, here we have the cached layer, and we have the uncached layer. So if you go to the cached layer, you can see the 99% percentile is responding at 9,300 milliseconds. Not so good. You can test it with a small number, but you can see this is the value. And you can see there is some difference based on, it's the same layer, but one is cached, another one is not. But you can see the difference here, and you can see if there is any fails that have happened and the average as well. So you're able to see that there is quite some difference rather. So it means that maybe based on what you are doing with the experiment you are doing, you might see a substantial difference, because surely it should be. But in our case now, we have this as they are very close. So I'll just maybe reset that, and then I can try maybe the final part, Abdul, as before I finish. So I can do 50, just a small test, and we see, and then we can update that. So this is, I've done it with 50 users, and you can see now they are kind of already spawning, and you can see now the value is kind of now it has interchanged, yeah. But over time, it should pick up. You see now it has kind of surpassed that. Why? Because now this one is kind of creating on the fly sometimes, because some are not cached, and this one is not cached at all. So you see there is some substantial difference in the two. Yeah. So that is ideally now the part where maybe you can let it run as long as you want. You can configure a lot of things, and you can see exactly how your server responds. You can add this to even more, so that you kind of see where it breaks. You can add one, and I had 100 something. So just so that you see, even at some point, GeoServer will not respond, meaning that it can't handle the load. Yeah. Basically, that's it from my end. And yeah.